Hello everyone. In this lecture, we're talking about chapter 5, programming language, and this lecture for English version student. As you know, that programming language, this chapter has two parts. In the first part, we're talking about algorithm and flowchart, and the second part, we're talking about C programming or coding. As you know, that in chapter 3.1, in the last portion, we're talking about a word is code. This code and this coding is two different things. So this thing keep in your mind. Now the question will occur that why we need to learn the programming language. Okay, so for that purpose, we can take an example, and one word always be said that everything in the world can be possible to convert in the programming language. The question is how. Just imagine you are a student. This is you. Okay, and you have to wake up in the morning at 7 p.m. You have to go to college. You have to back from your college, or you have to go to private or coaching. Then you have to study at 7 p.m. You have to go to sleep at 12 p.m. So all those things you have to think in your mind that after one things, the another thing you have to do. Okay, I mean step one, step two, step three, step two. This is the format you are thinking in your mind, and this same concept we are using in the programming language. That's why we are saying that everything in the world can be possible to convert in the programming language. We can also take another example. The example is that you have a laptop and, and you have a pen drive. And this pen drive we want to attach in the laptop. And this laptop, it will show that how many free space in that. It will be 16 GB, it will be 32 GB. Now, take another example. If I consider you, that means your hand or your finger. We want to attach this finger in this laptop. It will be possible for the laptop to tell me that how many free space in your body, how many free space, free space in your body. It will be say that in your body there is a 16 GB or 32 GB free space. Obviously not. That means I will say this laptop are not able to recognize you. This laptop able to recognize this pen drive. That means there is a must be a relation between them, and this relation we can be established by using the programming language. Okay, now take another example. Simple example. We want to design a simple calculator. This calculator can add only two numbers. The number is 4 and 5. So the 4, the plus 5 equal 9. And these things we have done a lot of times in your regular life. But what actually happen if I break down this calculator? That means I'm talking about the inside part of the calculator. If I break down this calculator, inside part we'll able to get the motherboard. Okay, so this 4 and this 5 go to the motherboard, and this 4 will be converted into 1001. That means the decimal number will be converted into binary. And this is not enough. It is not like that there is a number is 4 and it will convert it into 101. We need a design device for that. And this device name is encoder. Name is encoder. That's mean I can say the device which convert that human language to the machine language. Machine language is called encoder. That means this 5 will go to 101, and there is another device is encoder which convert this human language to the machine language. And I want to add two numbers, and for this purpose we have to use adder, binary adder, and that we have also know how to add in binary. That's why we learn binary addition. Binary addition. Then I get the result 1001. I'm not showing this result to my display box. Okay, so this is my display box. This is my display box. I will not show this result in this box. I will show the result is 9. That means I need another device is convert this machine language to the human language. And that for that purpose, binary to decimal I have to convert. For that purpose, I use a device. The device is decoder. That's when I would say the device which convert the machine language to the human language is called the decoder. And all those terms basically refer chapter 3. And this is all the board question. All the board questions. Okay, that's mean I can say that chapter 3 that we already ran in the previous lecture basically represent the hardware part of a device. And the thing we learn from chapter 5, this represent basically the software part. And always remember, a device is active when its hardware part and the software is combined. Take an example that you have a mobile phone, and this is a touchable part, and this touchable part is converted as a hardware. If I talk about software, just imagine you are using some application. This is would be Facebook, this would be Messenger, this would be WhatsApp, contact list, messaging, all those things. The app we are using in the inside, this is the software part, and this device will be activated when the software part and the hardware part is combined. Okay, so this is some basic concept of the chapter 5, the programming language. And in this chapter, we to solve the problems of this chapter, I will design a format where I have to write down some question and the corresponding answer. So I will write down at least 30 questions. So first we will get the question, and then we write down the answer accordingly. Okay, so the first question, write down an algorithm, the flowchart, and C program. That's mean in one question there is three part: algorithm, flowchart, and C program to add two numbers. To add two numbers. So first, write down the solution for the algorithm part. Okay, so what is the question? The question is that to add two numbers. So just imagine that you have a two number 4, 5, and you want to add this two number. So the format to write down the algorithm is step 1, step 2, step 3. This format we are using. So step 1 is start. Now tell me, what is the question? The question is that to add two numbers. That's mean if you want to add two numbers, that's mean in this calculator, you have to press two numbers. That means I have to press 4, 5. So I can write down press two number. Press two numbers, but it's not like the proper word we are using. So you can write down input two numbers. Okay, now go to step 3. So what will be the happening in step 3? That means when I write down place to number 4 and 5, that means this figure actually happening. This figure, when I write down 4 and 5, and this 4 and 5 go to the motherboard. This 4 and 5 go to the motherboard. And in motherboard, all those things basically happen. That means this 4 will convert 101, 5 will be convert 101, the addition will occur and get the result 9. That means in this part, the summation part will be happened. Okay, so that's mean in step 3, we write down simple the word is summation. But when you write down the word summation, you have to keep in mind that what actually happening. That's mean all those things basically happen or quite related to the chapter 3. You don't need to write down in the exam paper, but keep in mind. Okay, so when I get the result summation, that means the result is 9 in the motherboard. Okay, and now I have to show the result in the display box. So that's why step 4 is print result, or you can say print sum. When I get the result, so my work is done. So step 5 is stop, or you can write down end. Okay, so this is the algorithm part. Now this algorithm I want to convert the flowchart format. Okay, so this is my algorithm, and I want to convert this algorithm to flowchart. Okay, so now tell me, what is the first line? First line is start, the last line is stop. So my algorithm, in my algorithm, sorry, flowchart, the first symbol is start, the last symbol is stop. And what is the symbol name? The symbol name is ellipse. Always keep in mind that is not circle. This is not circle. Okay, now go to the second line. What is the second line? That means step 2. Step 2 input two numbers. And what is the fourth line? Print result or sum. So for the input purpose, And for the output purpose, I am using the same symbol. The symbol is parallelogram. The symbol is parallelogram. So the second line, the step two, is input number. So you can write down these things input to numbers, but I want to write down this thing as a mathematical format. So you can write down input A, B. Input two numbers and input A, B is the same things. Okay. And the last line, print sum. So you can write down print sum as usual. Okay. And what is the third line? The third line is summation. So for the summation, the symbol we use is rectangle. Rectangle. And I write down summation. And I want that you not write, don't need to write down summation. You write down sum equal to A plus B. That means I want to represent the flowchart as a mathematical format. Okay. So it is quite easy for us to understand. Okay, so now in algorithm part, we write down step one, step two, step three, step four, and step five. But in flowchart, there is no step one, step two, step three. So for that purpose, we use a arrow symbol to understand the step by step how actually it will be going on. And one thing always keep in mind that every algorithm, every flowchart has three parts. The first thing, the first part is input. The second thing is process. And the third thing is output. That means every program, every flowchart, every algorithm has three parts: input, process, and output. Now tell me, there is any difference between algorithm and flowchart? Actually, no. Basically, there is two things. The algorithm is the script language, or I can say that is the paragraph format, and this is some symbolic format. And in the exam paper, the symbol is quite important. Okay, if you are any mismatch of the symbol, you will not have to get the full mark in the exam paper. So you have to always keep in mind ellipse, parallelogram, rectangle, ellipse, for input output which symbol we use, for process which symbol we use, for start and stop which symbol we use. So this thing will be mandatory part. Okay, and this is all about today's lecture. In next lecture, I will talking about the programming. Okay, so this is all about today's lecture. Thank you.